ANCOVA is used when a study needs to compare group means on a numeric outcome, while also accounting for another factor that could be influencing that outcome. It is chosen when the research problem and literature gap point to differences across groups, but the field recognizes that the groups may not be starting from the same place. Instead of pretending those differences do not exist, ANCOVA adjusts for them so the comparison is more fair. One way to understand ANCOVA is to think of it as ANOVA plus a fairness adjustment. ANOVA compares group averages exactly as they are. ANCOVA still compares group averages, but it does so after adjusting for one extra variable that would otherwise distort the comparison. That extra variable is called a covariate. A covariate is a numeric variable that is related to the outcome and may differ across groups, such as a pretest score, prior achievement, baseline motivation, or previous GPA. The covariate is not the main focus of the research question. It is included to clean up the group comparison, not to explain the outcome by itself. ANCOVA is designed to address a very common problem. Sometimes groups differ on the outcome not because the program or condition mattered, but because the groups were already different before the study began. If one group starts higher, they may also end higher even if the intervention had no real effect. This is where ANCOVA changes the question being asked. ANOVA asks which group ended higher. ANCOVA asks if all groups had started at the same level, which group would have ended higher. That shift is the core logic of ANCOVA. Imagine two groups. Group A begins with higher pretest scores and ends with higher post-test scores. ANOVA might suggest Group A performed better. ANCOVA asks whether Group A would still end higher after adjusting for the fact that it started higher. If the difference disappears after adjustment, the apparent advantage was mostly due to baseline differences rather than the treatment or condition. For example, 3 instructional models are compared on post-test achievement. Students complete a pretest at the beginning of the term and a post-test at the end. The instructional model is the grouping variable. The post-test is the outcome. The pretest is the covariate because it captures where students started. ANCOVA adjusts the post-test comparison so the instructional models are compared as if students had started at the same pretest level. A different example could be in-person, hybrid, and online formats may be compared on final exam scores while controlling for midterm exam scores. Another way to use an ANCOVA could be for tutoring participation groups, may be compared on end-of-course math achievement, while controlling for prior math GPA. Counseling formats may be compared on post-intervention stress, while controlling for baseline stress. Professional development models may be compared on post-efficacy, while controlling for baseline efficacy. In every case, the covariate represents a background factor that could otherwise make the group comparison misleading. ANCOVAs use adjusted means. Adjusted means are not raw averages. They are estimated group means that represent what each group's outcome would look like if everyone had the same covariate value. ANCOVA first accounts for the influence of the covariate, then compares these adjusted means. When results are interpreted, conclusions are based on adjusted means, not original means. Controlling for a covariate does not mean removing it from the study or ignoring it. It means separating out the portion of the outcome that is associated with the covariate, so that group differences are less influenced by baseline or background differences. Because ANCOVA changes how group differences are evaluated, wording and alignment matter. The research question must explicitly state that group differences are examined while controlling for a covariate. That phrasing signals that the analysis is ANCOVA rather than ANOVA, and helps prevent causal overstatement. Is there a statistically significant difference in post-test achievement scores among the 3 instructional model groups after controlling for pretest achievement scores? ANCOVA requires 3 components. There must be a categorical grouping variable with 2 or more independent groups. There must be a numeric outcome variable. There must be a numeric covariate measured consistently for all participants. The covariate must be conceptually justified based on theory or prior research. It should be measured before the outcome, related to the outcome, and not caused by the treatment or group condition. Controlling for a variable that is influenced by the intervention can distort results rather than clarify them. ANCOVA relies on the same core assumptions as ANOVA, and adds one important assumption related to the covariate. These assumptions matter because ANCOVA is making an adjusted group comparison. If the assumptions do not hold, the adjustment is no longer fair or meaningful. The first assumption is independence of observations. Independence means that each participant's score represents one person and one experience. One participant's outcome should not depend on another participant's outcome. In dissertation research, this is mostly about design. If the data come from individuals who influence each other, or are tightly grouped in ways the study does not account for, the comparison of group means becomes less trustworthy. The second assumption is that the outcome behaves like a continuous, approximately normal variable within each group. In plain language, ANCOVA assumes the outcome is something that spreads out naturally across people, not something that is heavily piled up at one value or restricted to a few possible scores. When outcomes behave this way, comparing group means make sense. When they do not, mean comparisons become harder to interpret. The third assumption is that the groups have reasonably similar variability on the outcome. This means that no group scores are wildly more spread out than another group scores. If one group shows much more variation than the others, it can distort the group comparison and weaken the conclusions. Next, the covariate must relate to the outcome in a consistent way across groups. This is the most important additional assumption in ANCOVA. In simple terms, the covariate has to work the same way for everyone. If higher pretest scores predict higher post-test scores in one group, but not in another group, a single adjustment is no longer fair. In that situation, standard ANCOVA is not appropriate. A useful way to summarize the assumptions is this. ANCOVA assumes that group comparisons are meaningful, that the outcome behaves like a true numeric score, that the covariate is relevant, and that the covariate influences the outcome similarly across groups. The ANCOVA answers one question. Is there a statistically significant difference among groups on the outcome after controlling for the covariate? If that test is not significant, interpretation stops. If the test is significant, and there are more than two groups, post-tests are used to determine which specific groups differ. These post-tests compare adjusted means and use a correction for multiple comparisons. If there are only two groups, no post-test is needed because the adjusted mean difference already answers the question. Interpreting ANCOVA results should follow a clear sequence. First, state whether the ANCOVA was statistically significant, and explain what that means in plain language. Second, interpret adjusted means, identifying the direction of differences. Third, report and interpret effect size to describe practical importance, not just statistical significance. Fourth, report post-test results if applicable, using adjusted mean language. Finally, return to the research question and restate the finding using the phrase after controlling for the covariate. One final clarification is essential. ANCOVA does not prove causation. Unless the study uses true random assignment, the correct conclusion is that groups differed after controlling for the covariate, not that the intervention caused the difference. ANCOVA strengthens group comparisons, but it does not eliminate all bias or replace experimental control. If the covariate does not relate to the outcome, the adjustment adds little value. If homogeneity of regression slopes is violated, standard ANCOVA should not be used as planned. One final note helps place ANCOVA within the broader family of statistical tests. ANCOVA is used when there is one numeric outcome and the goal is to compare group means while controlling for a covariate. When there are multiple numeric outcomes analyzed together, the same logic extends to ANCOVA. When the goal shifts from group comparison to prediction or explanation of variance in an outcome, regression becomes the more appropriate framework. Thinking of ANCOVA as a bridge between ANOVA and regression helps clarify its role. It is still a group comparison test, but one that borrows the adjustment logic of regression to create a more fair and interpretable comparison.